All right, guys, let's go through this advanced theory transformers test. It's for our second test here. I hope you have a large copy. There are 79 questions to get through, so a disgusting amount of information, but by the time you're done, you'll be well ready for the second test. This first question here is providing you with the primary and the secondary diagram of our three-phase transformer. And you've got to figure out what the primary is and what the secondary is. We can see that our primary is here because we have H1, H2, H3. Our secondary is on this side, and then we have X1, X2, X3. And we got to see whether it is a Y, a delta, or an open delta here. So let's see. We've got this connection right here for this winding, and it seems to go to H1. And I'm going to label that guy A, because that's our A phase. Then we've got B. Then we've got C. So that's going to help because I gave you that mnemonic to remember. Because we know that for a Y, everything's tied together at that star point, which it doesn't seem to be the case on this guy. Not everything is brought together. So it must be a delta. And the rule for a delta is that we've got A to B, B to C, and then C back to A. So A to B, B to C, C back to A. And let's see if we've got that. Well, we've got a connection here for this transformer from A. The other side of that winding ties into B. The next winding goes from B and then ties into C. So we got B to C, and then finally we have C back to A. So A to B, B to C, C back to A. We have a delta on our primary. Okay, I said open delta, but that doesn't seem to be an option right here. So it's either a Y or a delta. Again, on the secondary, we're looking for everything being tied together at one point for a Y, which it doesn't seem to be the case. So let's see if we're going A to B, B to C, and C back to A. So let's see, we got this point right here, which is referencing A. This references our B, so A to B for this guy. Then over here, we've got this side of the winding referencing B. The other side of the winding is referencing C, so this is A to B, B to C, and this guy is C. And the other side is going all the way back to A. So the secondary is also a delta. Okay, our deltas have 3 wires in Canada, so this guy is a delta to delta, so one is A here. If we scroll down to our next question here, this transformer has, well, it's a delta to delta, so we need 3 wires on the primary and 1, 2, 3 wires on the secondary. So where do we have that? That looks like D is the answer here for this guy. Again, I'm rocking and rolling. I got 79 questions to get through. So download the another copy of this, work through it on your own, and then start and stop the video on each page to double check that you're on the right track. Number 3, the ratio of this transformer is 2.88 to 1. Okay, so now we got to go back up to here. The ratio here is 2.88 to 1. And we know that that is on the phase, right? So let's see, we have 600 volts on the phase that's given. And we know that on a delta, the 600 volts is both the line and the phase. So we have 600 volts on the line, and we've got 600 volts on the phase. And if that guy is 2.88 to 1, then we're going to have a lower voltage on the secondary. Okay, so let's bring up the calculator here. We'll do a quick little calculation. We have 600 volts. We can clearly see that the voltage is lower on the secondary. So we're going to divide by that ratio, 2.88. And that gives us 208 volts. And because we have a delta on the secondary, that's going to be 208 volts on the line and 208 volts on the phase. Okay, so let's go scroll down and see what they were asking us for. Secondary voltage. Okay, so that one is, I haven't specified line or phase, but we know that they're identical. So 3 is C. Secondary, the transformer requires a neutral conductor. Well, for this guy, we have no reference for the neutral whatsoever. It's a delta. So for this guy, we do not need a neutral. Beautiful. All right. As we go through, just check each page, right? So this one was a delta to delta. If you got all these correct, then don't look at this one again. Only look at the ones that you're screwing up as you go through. Next one, guys. So what have we got? We've got to take a look and see whether we've got A to B, B to C, C back to A, or whether we've got everything tied together. This one, I just want to clean this up a little bit. This has a jumper right across these guys right here. So if you don't see that connection there, we have a jumper. So for this guy, it looks like we have all of our X2s on the secondary, this X2, and this X2, and this X2 all drawn together. And it's clearly shown that that guy is going down to the neutral, and the neutral is grounded. So on the secondary, we're going to have a Y. Okay, so let's draw that in. We've got on our secondary is a Y configuration there, because we have the star point right here, and that star point is clearly seen with each of these points being brought to the same potential. Right, then we have line 1, line 2, line 3, and we can see here that we've got line 1, line 2, and line 3 coming off of our outside connections here. Okay, so the Y secondary, let's see what we have on the primary. Well, it looks like the same. It looks like we have a jumper right here, and a jumper right here, and we've got a connection between this point on the H2, and this H2, and this H2 right here, and they're all brought to reference this neutral conductor right there. Okay, so this one is also a Y on the primary. So our answer here for number 5 is C. We've got a Y to Y, and it looks like we've brought, based on this diagram, we have a 4-wire on the primary, and we have 1, 2, 3, 4-wire on the secondary. So we need an answer there for 4-wire on the primary and 4-wire on the secondary. So 6 is B. Okay. Next one, if the primary line voltage is 4160 and the ratio of the transformer is 8.67 to 1, secondary voltage is, all right, well, this is going to require a quick little diagram here, guys. Okay, our primary is a Y, so let's do our primary here. Okay, then we've got a secondary there, which is also a Y. Okay, and then we got to put our voltages on there. So on this guy we have 4160 from line to line. Okay, and then on our secondary we don't know anything yet. Our voltage here on the phase is going to be √3 less. So let's bring up the calculator and double check that value. So we've got 4160 divided by √3. And that gives us 2401.77. Okay, and that is our phase voltage. Now the ratio there is 8.67. Now, because this is a mirror image, meaning that this is a Y and this is a Y, both the line ratio and the phase ratio will be exactly the same at 8.67 to 1. So let's take our line voltage of 4160. And we're going to drop the voltage by a factor of, what was that ratio again? 8.67. So we're going to divide by 8.67, and that gives us 479.81, which we know is 480. So our line voltage over here is 480. And we know that, easy now, we know that the phase voltage is going to be 277 volts phase to match that, right? So let's just double check. 2401.77. And we're going to divide by that same ratio of 8.67 to 1. And that gives us 270 volts. Beautiful. So we've just shown that we got the 480 based off of 4160. So 4160 divided by 8.67 gives us 480. 2401.77 divided by 8.67 gives us 277. So C is our final answer. Okay, out of those guys, because you're tight for time on this one, right? So I would have just taken the line voltage, done 4160 divided by 8.67, found that the line voltage was 480, looked over here, that's only one option right here, so the answer is C, and you move on. If you have time, double check your phase values as well. Secondary of this transformer requires a neutral conductor, for sure. That guy's going to feed a three-phase load, and any unbalances are going to come back on as a neutral, right? So there's our neutral right there. Okay, so for 8, our answer is true. All right, so we've got 8 questions, and looking at my time here, I'm at 11 minutes so far. So we're doing pretty good. I'm doing a lot of talking on each of these questions, but you should be able to rock through each of these at like 30 seconds each. Maybe a little bit of time here for this calculation. Let's look at the next one, guys. Number 9. So again, I'm going to give you as many different diagrams as I can, and you've got to see whether it's a Y or a delta configuration. So with this one on the primary, again, we're either looking for everything being tied together at a certain point, or we're looking for A to B, B to C, and C back to A for a delta. So we can clearly see 1, 2, 3 lines and a neutral. So we know that this guy is a Y right here. All of these points right here are brought to the same potential, and that's providing us with our neutral connection. So we have a Y in the primary. And then on our secondary, again, we have all of these guys being brought to the same potential here, and then coming out to reference our neutral there as well. So we have a Y on our secondary. So we have a Y to Y three-phase transformer. So 9 is C. Okay, let's take a look at the next one. Well, this one's, if you take a look at these diagrams, this one's different than this guy right here, right? So most likely this is going to be a delta, but let's just make sure. The rule for the delta, remember for the delta it was A to B, B to C, and then C back to A. Okay, so let's see. We've got this winding right here that is referencing A. So I'm calling this guy A, B, and C, right? So we have this going A to C. This guy here is A to B. And this guy is B. And the other side of the winding is referencing C. So we have A to B, B to C, and then C back to A. So it's clear that the primary here is a delta. On the other side, it's the identical diagram here, where we have A, B, and C. And again, we've got A to B, B to C, and then C back to A to close the delta. So secondary here is a delta. And that corresponds with A. Beautiful. Okay, let's take a look at number 11. Okay, this one looks like it has 1, 2, 3, 4 conductors. These guys are all brought together to the same potential. So our primary is a Y. And on our secondary, again, we have A to B, B to C, C back to A. And so this guy is a Y to delta transformer. So that way would be B for number 11. All right, so number 12 now, guys. Let's see, we've already done all the other combinations. So this one here is most likely going to be a delta to Y because we haven't seen that one yet. But let's just double check. On this guy right here, we again will label this one A, B, and C. And so we've got A to B, B to C, C back to A. And so our primary is a delta. Okay, on the secondary, we have each of these points right here coming together, referencing our neutral. We have 4 wires on our secondary. So this one right here is a Y secondary. So a delta to Y transformer. So 12 is D. Okay, let's look down at number 13, 14, and 15. So the ratio of primary line voltages and secondary line voltages versus primary phase voltages and secondary phase voltages are identical. So if you have a delta to delta, just think of them as a mirror image. Or a Y to Y, that's a mirror image, right? So the line ratio and the phase ratio are identical in both the delta to delta and the Y to Y transformers. So 13 is A. If we take a look at 14, line voltage sine waves at the secondary are in phase with the line voltage sine waves of the primary. So that's saying, where are they in phase? Are they in phase in a delta to delta configuration, or are they in phase in a delta to Y? Well, again, these guys are a mirror image of each other, and the Y to Y is a mirror image of each other. So there's no phase shift on a delta to delta or a Y to Y transformer. Whereas when you have a delta to Y or a Y to delta, then you're going for more of a parallel to a series combination, or a series to a parallel combination. And with those guys, they're actually 30 degrees out of phase, meaning that your primary sine wave and your secondary sine wave are no longer in phase. They're 30 degrees phase shifted. So 15 is B. Okay, let's take a look at the next one. So again, I'm going to give you all kinds of diagrams that I found of delta and Y configurations. So the first thing we need to look at is whether this one is a delta or a Y. So remember, for the delta, it's A to B, B to C, C back to A. And here we have different phasing that we're used to in Canada, but this is our A with the black, B with the red, and C with the blue. So for here, we have the A phase coming down. So this side of the transformer is referencing A. The other side of the winding is coming over here and referencing B. So A to B. This one here is B, so this side of the winding is B. The other side of the winding comes over and references C. And this final winding here goes from C, and the other side of the winding goes back and references the A. Okay, so we can see there that our primary is a delta. And if we look at our secondary here, let's see. And that's a little bit misleading, right? Because for one thing, there's a neutral here, but it's not being used whatsoever. So be careful. There's all kinds of tricks here trying to mess you up. On the secondary here, we have line 1, line 2, line 3, and we do have a neutral. And there is a conductor tied into the neutral right here. And we can see that this X2 and this X2 and this X2 are all tied together at a star point and referencing that neutral conductor. So our secondary here is going to be a Y. Okay, so answer here, let's see, delta to Y, 16 would be D. And for this guy, we have to count our number of conductors on the primary and the secondary. Well, in the primary, we seem to have 1, 2, 3 conductors. And the secondary, we've got 4 conductors. So 3 wires in the primary and 4 wires on the secondary. Best answer out of these guys looks like D. Okay, then we're looking at the primary line voltage is 600 volts and the ratio of the transformer is 5 to 1. Secondary voltage is, so let's take a look at, and I'm asking you for both the line and the phase, right? Because I've given you both values right here. Let's do a quick little diagram and we'll try to figure this out. So going back up, we have a delta on the primary, a Y on the secondary. So let's do our delta on the primary. Okay, then we're going to do a Y as our secondary. Okay, and then we're going to look at our voltages there. And the voltage given on the primary is 600 volts. It doesn't say whether it's the line or the phase voltage, but we know for a delta that those guys are identical. So we have 600 volts on the line, and we have 600 volts on the phase. Okay, the ratio is 5 to 1. So here, that would be on the phase, right? So remember that the ratio is on the phase. So let's just make a note there. We're going to say that. That's going to be right here. Ratio is based on phase value. So don't get tripped up throughout this test. The transfer of energy is here. Like if we say this is A, that transfers its energy over here. B transfers its energy over here. And C magnetically transfers its energy over to here. The transfer of energy is on the phase. So the ratio is on the phase as well. Okay, so let's take a look at our voltages now. If we have a ratio of 5 to 1, that means it's a step-down transformer. And here for our secondary phase voltage, it'll be 600 divided by 5. And that ends up giving us 120. So the ratio is on the phase, right? We have a ratio of 5 to 1 on the phase. And that gives us 120 volts on our phase value. And then we know that our line voltage is 208 volts on the line, root 3 of our 120. So secondary voltage is 120.28, and it looks like D, oh, this guy's all D all the way through. Okay, so D, D, and D for 16, 17, and 18. Secondary of this transformer requires a neutral. Well, we have a Y. Those guys are going to be feeding a number of loads, and we'll have a neutral that definitely goes back to that Y connection there. So 19 is A. Okay, we've been at this for quite a while, guys. Let's take a break. Check out the next video in the playlist, and we'll continue on at question number 20.